Hello, Professor McMath here. Welcome back to another exciting mathematics video. Today we're going to be finishing up our topics on radicals, and we're going to talk about how to solve a radical equation. By radical, I mean square root equations, not like radical in terms of radical, opinions or anything like that. So again, a radical equation is one that has the variable inside the radical itself. So it could be inside a square root, inside a cube root, a fourth root, and so on. We're going to focus only for this particular year. We're going to limit our focus to just square root functions and how to solve those. Though the rules for solving a square root function can be easily applied to solving a cube root function or fourth root or whatever it happens to be. So the process of solving this is very straightforward. You have to isolate the radical. You move everything that's not the radical over to the other side of the equation. There are also technically equations of this type that include multiple radicals in there. Again, we're going to narrow our focus and not talk about that this year, though depending upon by the end of the year we might include ideas for that as well. So once we have this radical isolated on the one side, we square both sides to eliminate the radical. Again, the opposite of the radical is the squaring. That's why we do the opposite operation to eliminate it. From there, it should look familiar. It should be a linear equation, maybe a quadratic equation, something that you know how to solve. Very important though, and you must show that you do this. You have to plug your answer back into the original equation to make sure it works. There are plenty of times where your answer might have resulted in, if you plug it in as like -1 equals 1 situation, which obviously is not true, but if you square both sides, they both result in the same thing. That's why it's important to always check your answers for every single radical equation. It might seem a little tedious, it might seem like it's going to waste you time. It is not, because I guarantee you on different questions that you will see, there will be times you'll get, if you write an answer down that doesn't actually work, you're going to lose a lot of points. So always check it. So we'll start off with the basic one. So we have the square root of x plus 5 and plus 7 equals 12. So the idea is everything that's not the radical has to be moved to the opposite side of the equation. You have to isolate the radical expression. So again, the 5 and 7 can't combine because the 5 is inside the radical. So I'll subtract the 7 over. And we get the square root of x plus 5 equals 5. Well, now that the radical is isolated, we just simply square both sides. Squaring the left side cancels the radical, leaving just x plus 5. And then squaring the right side, well, 5 squared is 25. We solve for x by subtracting 5. And x equals 20. Again, it appears to be the answer, but we should always, good mathematics for the radicals, we always have to plug it in to check. So we have the square root of 20 plus 5 plus 7 equals 12. Square root of 25, which is 5. 5 plus 7 is 12. And both sides work. So x equals 20 is the solution. We want that. Always do the check step. If you do not do the check step, you actually will lose points on a quiz. So for this expression, we have a couple things going on outside the radical. We have a 2 and a -6. First thing to remember, PEMDAS, we multiply before we subtract. So I can't combine the 2 and the 6 together. I have to move the 2 over. Since it's positive, we subtract it to move. And then we have to divide by the -6 to cancel that, and leave with just the radical 2y plus 5 equals 2. So, it equals 2, so we square both sides. And we get 2y plus 5 equals 4. So if we subtract 5, we get 2y equals -1. Divide by 2, and it appears that y equals -1/2. Again, always need to make sure we check our work, so we're going to plug it back into the original. So it'd be 2 times -1/2 plus 5 inside the radical. And the whole goal is to make sure the left-hand side equals a -10. Well, 2 times -1/2 is -1. -1 plus 5 is 4. Square root of 4 is 2. 6 times 2 is 12, and then 2 minus 12 is -10. That's what we want. Both answers work. Again, you need to make sure you check every single question. Generally, though, if when you're squaring both sides, you're squaring a radical and you're squaring a number, You generally don't actually have to check it to make sure it really does work. Those problems will always work out in that particular case. It is still a good habit to get into for problems where it's a variable you're squaring, and that's where you're going to generally have what we call extraneous solutions, answers that seem to work algebraically but really don't. That's why I want you to get into the habit of doing it every single time, so that's why I'll require it on every single problem. So we're trying to isolate the radical here. We'll subtract the 14 from 9 first. 9 minus 14 is negative 5. Divide by the 5 and we'll get negative 1. Now, a couple things right here. We can stop right there and say our answer. Because the square roots, algebraically, will always result in a positive number when we take it. The only times we talk about a negative answer from square roots is like when we're solving the equation like x squared equals 9, so we'll say plus or minus 9. The square root cannot yield a negative number on its own, so since we're saying square root equals negative 1, we can stop right now and say the answer is no solution. If you ignored that and you actually solved it out, so if you squared both sides, you'd get 3a minus 4 equals 1. So 3a equals 5, and you'd be thinking a is 5/3. And this is where the check comes in so nice. If you plug in the 5/3 back into the original equation, 3 times 5/3 minus 4, we're going to get a 5 minus 4 on the inside, which is 1. Square root of 1 is just simply 1. 5 times 1 is 5. 5 plus 14 is 19, and 19 does not equal 9. So that would also then tell you right off the bat that it doesn't actually work, and therefore if there's no answers, then the answer is no solution. However, to save yourself a lot of time and effort, recognize once you have the radical equal to a negative, you're done, your answer is no solution. Now, for these problems right here, we're now noticing our radical is already isolated, but now there's another variable in the problem. It's on the other side of the equation. To solve, we still have to square both sides, so that's the only way to get rid of the radical. The difference now is, instead of squaring a number, we're squaring an expression. So we need to make sure we're very careful. When we square out k minus 1, we need to make sure we get the full trinomial, k squared minus 2k plus 1. So we now need to recognize this is a quadratic. Where to solve a quadratic, we generally say it equal to 0, so we have to move the k plus 1 to the right side. And we'll find we get k squared minus 3k, and the 1's cancel. So to solve this particular problem, we have to factor it. It's not a trinomial, so we can't go through the reverse FOIL process. We recognize, like we discussed in the factoring videos, that they both have a k in common, so I can take a k out, leaving k minus 3. So we can say k equal to 0, which just means k equals 0. We can say k minus 3 equals 0, which means k equals 3. So we have two possibilities. Now, for these particular equations, these are the ones that you are generally going to have an extraneous solution where one or both the answers don't actually work, which is why it's so important to plug in. Plug the 0 in first. We get the square root of 0 plus 1 equals 0 minus 1. We get square root of 1 equals negative 1, and 1 does not equal negative 1. So 0 doesn't actually work, even though it seemed to work. We then plug in and the reason why it seems to work is because if you were to square right now, 1 and negative 1, you get positive 1s on both sides. That's why it appears to be an answer, even though the original ones isn't going to work out. Plug in 3 now. Square root of 3 plus 1 versus 3 minus 1. We get square root of 4 equals 2. 2 equals 2, and that's fine. So our answer is k equals 3. Don't assume that the answers can't be negative. The variable is allowed to be negative. That's fine. Don't assume that the variable has to be the larger of the two. It's entirely possible to design problems where negatives work, where the smaller of the two numbers work, anything like that. So always work through all the answers and always check all the answers. So for this expression right here, again, the square root is isolated, so we square both sides. On the the left side we get 9 minus 6x plus x squared. On the right side we just get x minus 1. So again we see an x squared term, so we tell this is a quadratic. So first off we'll write in the proper order, so it'll be x squared, and when I move the x and the negative 1 over, I'll get minus 7x plus 10. So this is a trinomial which we can factor by reverse foiling it. So the factors of 10 that add to be -7 are -5 and -2. So we have possibilities of x equals 5 and x equals 2. And again, both answers need to be plugged back in to check. So if we try 5 first, the first one, we get 3 minus 5 equals square root of 5 minus 1. -2 equals square root of 4. -2 does not equal 2, so 5 doesn't work. We plug in 2. 3 minus 2 equals square root of 2 minus 1. 1 equals square root of 1. 1 does equal 1. So x equals 2 is the only solution then for this particular problem. So this is what I was referring to in the previous example. Don't assume the bigger number has to work. Easily designed here where the bigger number didn't work. So always plug them in to verify. Now, we have a square root expression, so we need to isolate it. And we have a variable on the outside. All perfectly fine. The key is moving the -5 over first by adding to make it the square root of x squared plus 9x plus 15, and then equals x plus 5. So since we have the square root here, we have to square both sides. Left side is just the inside, x squared plus 9x plus 15. The right side is the binomial, which we FOIL to get a trinomial. Should be x squared plus 10x plus 25. Well, this is kind of nice because you see we have x squareds on both sides. That means they cancel. So now we have a linear. So you got to get x together on one side. Move the 10x over to the left side to get -x. Move the 15 to the right side to get a positive 10. So x appears to be -10. Well, we now need to plug that in just to verify that this answer is going to actually work out the way we want it to. So we need to plug it back in. So we have the square roots, -10 squared, plus 9 times -10, plus 15, minus 5, equals -10. And then from here, we need to, well, we work it out. So -10 squared is 100, minus 90 plus 15. We get 10 plus 15, which is 5. Sorry, 25. And then we get 5 minus 5, which is -10. 0 equals -10. That's not true. So -10 didn't work, so since nothing works, this is really then no solution. And I'm sure that, yes, that seems like a total, like, oh my goodness, you've got to be kidding me kind of thing, because how is it possible that nothing actually works? But that's going to happen every now and then. So that's why it's so important, even if it says trivial as, this is going to always work, no big deal, why are we even worrying about this kind of thing? You still need to go through the full process and actually solve it out to make sure that it really does work out for you the way you want it to. Okay? So those are our radical equations. This is the last topic we had with the radical functions and radical expressions. So again, appreciate you guys watching, and then McMahon out.